questions were about three-dimensional solids. So we're finding the volume using cross-section. So they're going to tell you what shape the cross-section is, and the area of that shape is what goes inside of the integral. So you have to imagine these shapes popping up out of the paper. And the kind of nice thing about these ones is it'll tell you if it's dx or dy. Like the area problems, you kind of had to just graph it and look at what you had. These ones are going to come out and say it's perpendicular to the x-axis or perpendicular to the y-axis. So it's kind of nice, helpful. All right, so the first one says, the base of a solid is the region bounded by the x-axis and the graph of y equals square root of 1 minus x squared. So let's go ahead and graph that first. It's going to be half a circle. Remember we did the one that was x squared plus y squared equals 4. Then when we separated it, we got square root of 4 minus x squared. This is like that. We're just going to have the top half of a semicircle. But you can always just plug in numbers to get some values here. And I would just start with 0. If you plug in 0, you're going to get 1. So 0, 1. And if you plug in 1 or negative 1, it's not going to matter because you're squaring it. This would be 1. 1 minus 1 gives you 0. So you get negative 1, 0, positive 1, 0. And here is that semicircle. And so this is the base of the three-dimensional shape that we're looking at. So you have to imagine cross-section popping up out of the paper. And it says that they are, so I'm trying to toggle between these two tabs here. Cross-section perpendicular to the x-axis. So all of our cross-sections are going this way. It's going to be a dx problem. And they are squares. So I would draw a square off to the side here. And the base of your cross-section, the base of the shape is going to match up with upper graph minus lower graph, which is just going to be this minus 0. So square root 1 minus x squared. And then we're ready to set up the integral. So it will be integral from negative 1 to 1. And inside of there, we're going to put the area of the shape. So the area of a square, it's going to be base times height. For a square, they're both the same. So it's just going to be this squared, which is kind of nice because the squared and the square root are going to cancel. And it's just going to leave you with what's underneath. So 1 minus x squared. So it's antiderivative and then upper boundary minus lower boundary. So this antiderivative will be x minus 1/3 x cubed from negative 1 to 1. All right, if we plug in 1, we're going to get 1 minus 1/3. If we plug in negative 1, we're going to get negative 1 plus 1/3. Negatives are going to cancel. I have to keep going because all my answer choices are simplified down here. So we got to keep going here. Distribute the negative. So that'll be plus 1 minus 1/3. And then we're going to group these together. 1 plus 1 will give us 2. And then minus 1/3 and minus 1/3 would be minus 2/3. And then I need to get a common denominator. So this would be 6/3 minus 2/3. So 4/3. And so that one is B. All right, next one, they gave us this graph, which is kind of nice. That's helpful. Let me get to the other tab here so I can see what the question says. The base of a solid is the region in the first quadrant bounded by the x-axis, the y-axis, and the line x plus 2y equals 8. So right off the bat, we're going to have to rearrange this to be x equals or y equals, whichever way this goes. We're going to have to rearrange this so that one of the variables is by itself. Cross sections perpendicular to the x-axis. So going this way. So it's going to be a dx problem. So let me go ahead and get y by itself. We're going to subtract over the x and then divide everything by 2. So this will be negative 1/2 x plus 4. And it says that our shape is a semicircle. So here's our semicircle. The base of it matches up with upper graph minus lower graph, which the lower graph is the x-axis. So it's just going to be this, negative 1/2 x plus 4. And then we're ready to set up the integral. So it will be integral from 0 to 8. I know that's really small, but that's labeled as 8 there. Integral 0 to 8. And inside of there, we're going to put the area of the shape. So for a semicircle, it is 1/2 pi r squared. And the only mistake that sometimes happens here, people will just put this in for the radius. Just remember that's the whole way across, so that's the diameter. So you have to divide it by 2 to make it be the radius. Now this one, all the answer choices are all these decimals, so that means we get a calculator. So I'm gonna go ahead and type that in and we'll get our answer. So integral 0 to 8, and then 1/2 pi, and then inside of here, we're gonna have negative 1/2 x plus 4, all that's over 2, and then close the parenthesis, squared. So 1/2 pi r squared. There were a lot of fractions in there and fractions inside of fractions. If you don't want to type all that, you could go through and just divide everything by 2 and simplify that down before you type it. But just make it look exactly like it does on the paper, dx, and then we'll get our answer. So 16.755, which again, those answer choices are kind of small for me. Let me see. That one is C. All right, number 3, the base of a solid is the region in the first quadrant enclosed by the parabola y equals 4x squared, the line x equals 1 and the x-axis. All right, so let's get a visual of that. So we have the x-axis, and then we have the line x equals 1. So I only really need to graph this parabola between 0 and 1. And so if you plug in 1 for this, you're going to get 4. So that part of the parabola is going to look like that. The parabola would obviously go on over here, but we just need this section of it. So that's the base of this 3-dimensional object. Each plane section, that means the cross section, is perpendicular to the x-axis. They're going this way, and they are squares. So I'm going to draw a square off to the side. And the base of it is upper graph minus lower graph. This is a dx problem. And so it's just going to be this 4x squared. And then we can set up the integral. So it'll be 0 to 1. And inside of there, you put the area of your shape. So it would be the area of this square. So 4x squared squared. So we're going to need to square that. That would be 16x to the 4th. And then antiderivative would be 1/5 x to the 5th, but there's a 16 there. So it'll be 16/5 x to the 5th from 0 to 1. Upper boundary minus lower boundary. If you plug in 1, you're just going to get 16/5. If you plug in 0, you get 0. So that's gone. So just 16/5 is our answer. So D for that one. All right, number 4. Let R be the region in the first quadrant bounded by the y-axis, the x-axis, and the graph of y equals e to the negative x squared over 2. I'm going to be really honest. I would not worry about what that graph looks like. It says we're going to use the x-axis, the y-axis, this graph, and the line x equals 3. All right, here's what I would do, honestly. And I'm not telling you to be lazy. I'm just telling you to be efficient. Just draw something. This graph is going to do something. It just really doesn't matter. We're going to use the x-axis, the y-axis, and x equals 3. So you're going to get some kind of area in there from 0 to 3. It doesn't matter precisely what it looks like. You just really need the boundaries, and they kind of told it to you because they gave you that x equals 3. So you have some kind of graph, some curve from 0 to 3. All right, and then it says cross sections perpendicular to the x-axis. So again, they're going this way. Again, are squares. So I'm going to draw a square. The base of it matches up with upper graph minus lower graph, which is just going to be this equation. It's this minus 0 for the x-axis. And so we're ready to set up the integral. It'll be integral from 0 to 3. And inside of there, you put the area of this shape, which is going to be this squared. So e to the negative x squared over 2 squared dx. All of the answer choices are decimals, so I know I'm going to be allowed a calculator, so I'm just going to go ahead and type this in. So integral 0 to 3 and then parenthesis e to the power negative x squared over 2, close parenthesis, squared, dx. So 0.886, and so that one is A. All right, number 5. So this one says the base of a solid is in the first quadrant bounded by the graph of y equals 2 minus 2/3 x, and the x and y axes from 0 to 3. All right, so to get a picture of that, this graph is linear. It went up 2, so we're going to start at 0, 2, and the slope is negative 2/3. So you would go down to over 3. So here is the base of this three-dimensional object that we're creating. It says each cross section perpendicular to the y-axis. All right, so here's a dy problem. This is going to be sideways. And as soon as you realize that it is dy, you immediately want to go and rearrange the equation. So I need for this to be x equals instead of y equals. So we've got to do the algebra here. So we're going to subtract over the 2. And then to cancel out the negative 2/3, I'm going to multiply by negative 3/2. That's going to get distributed through there. So that'll be negative 3/2 y plus, because the negatives are going to cancel. Actually, and the 2's are going to cancel as well. So just plus 3. So negative 3/2 y plus 3. It says the cross sections are, sorry, go back over to the other tab here, a rectangle whose height is 5 times its width. Right, so the base of this is going to be right graph minus left graph. Now the left graph is the axis, so that's just 0. So it's just going to be this equation, that negative 3/2 y plus 3. And the height is 5 times that. All right, so now we're ready to set up our integral. We need to use y values this time. It is a dy problem. Oh, I froze. Hold on one second. Okay, now that's unfrozen. So we're going to use y values for our boundaries. So it's going to be from 0 to 2. And then inside of there, we're going to put the area of our rectangle, which is going to be base times height. Now I would put the 5 out front, or you could leave it inside. It really doesn't matter, but that's a coefficient. And then it's going to be this negative 3y plus 3, or, excuse me, negative 3/2 y plus 3 times itself. Now you can write it as squared. The reason I wrote it that way is because we're going to have to do the algebra of multiplying this out. My answers are kind of nice. I don't think you'd be allowed a calculator for this one. They're not like all crazy 3 decimal points decimals here. So we're going to do this one by hand. It's good for you. It's healthy, like eating your green vegetables, makes your brain smarter. All right, so we'll get through it. So multiplying this together, it's just a bunch of algebra. Negatives are going to cancel. That'll be 9/4 y squared. The outsides are going to give you negative 9/2 y. The insides are going to give you negative 9/2 y. So together, that's negative 9y. And then 3 times 3 gives you 9. So it multiplied all that out. And now I'm going to do the antiderivative. So this would be 1/3 y cubed. But there is a 9/4 there. So multiplying that by 1/3, 3 times 4 would be 12. So again, it was 1/3 y cubed, but I multiplied the 1/3 by what was already there. All right, minus 9/2 y squared plus 9y from 0 to 2. I'm really running out of space, so I'm not going to bother with the minus 0. When you do upper boundary minus lower boundary, the lower boundary, if you plug in 0 for all these y's, it's just going to be 0. All right, so let's see what we've got here. Plugging in 2. 2 cubed is 8. Let me reduce the 9/12, so that would be 3/4. So we'll have 3/4 times 8. All right, 2 squared is 4, times 9 is 36, divided by 2 is 18. And then 9 times 2, oh, is 18. That's nice, those cancel. All right, so now I just got to multiply all this. 8 times 3 is 24. 24 divided by 4 would be 6. And then 6 times 5 is 30. So 30 for our final answer there. So D. And sometimes you do have to fight through all that algebra and the arithmetic of, multiplying all that together. All right, number 6. The base of a solid is a region in the first quadrant bounded by the graph y equals x cubed. So we have a cubic graph from 0 to 1. So let's go ahead and draw that. It's going to be at the origin, and we'll have the point 1, 1. It's going to wiggle like this. It said in the first quadrant from 0 to 1. So this is the base of our three-dimensional shape here. Cross sections are perpendicular to the x-axis, so they're all going this way, and they are semicircles. So the base of the semicircle is going to be upper graph minus lower graph, which is just going to be this x cubed. And our integral will be from 0 to 1. And inside of there, we're going to put the area of this shape, which is 1/2 pi r squared. And the radius is half of this. And the whole way across is the diameter, so we have to divide that by 2. All right, so this one does not look like we would get a calculator for this, so let me simplify this down. I'm going to take the 1/2 pi and put it out front. Anything that's just a value, you can kind of like evict it from the problem. All right, squaring this, x cubed squared would be x to the 6. 2 squared would be 4. So this is 1/4 x to the 6 dx. And then we're going to do the antiderivative. So this would be 1/7 x to the 7th, but there is a 1/4 there. So you just have to multiply those together. 7 times 4 gives you 28. 0 to 1. Again, I'm just going to plug in the 1. If you plug in 0, you're going to get nothing. It would just be minus nothing. So if you plug in 1, that would just be 1/2 pi times 1/28. And 2 times 28 will give you 56. So this will be pi over 56. So that one is A.